All right. In this video, we are going to see different data types which is used in PLC programming. And let's start with the first data type, which is Boolean. Boolean, in simple word, it's a bit. It could be either true or false, or in other words, we call it 0 or 1. So we receive this signal from push button sensor, whatever we connect with the digital IO to the PLC. Then after that, another data type which is integer. So it is categorized into two types. First is signed data type, another is unsigned. So in signed data type, we can store value in either in positive or negative manner. For example, we can store value like minus 100, or in plus you can say 300. Likewise, we can save. And here this is a short integer. It's a group of 8 bits. Then this is a group of 16 bits, which is integer. A double integer is a group of let me correct it here. It's 32 bits. Then L int is a group of 64 bits. And we use this data register to save the value from like a temperature deviation, pressure deviation, likewise. Then the next type is unsigned. Here we save the value in terms of positive way only. So we can store the value from 0 to, let's suppose, 100 or 2000, depends upon what integer we are going with, whether it is short integer. If it is short integer, then we can store value from 0 to 255. Why there is a limitation, we will explain. We'll see this thing in the next videos. Then we can use this data type to store the production counter encoder values. Okay, then let's move to another data type, which is floating data type. So most of the analog signals we receive from analog sensors like pressure sensor, temperature sensor. So we record this value using this real data type. It could be either for example 64.35 degrees Celsius, or if we are going with the L real, which means the memory size is a little bit bigger. It could be 1234.678. So the major difference is this decimal. Okay, so this is helpful while saving or storing the analog signals value. Then another data type is a bit string. It is nothing but like a group of 8 bits, which is byte. Then group of 16 bit, it's word. Then group of 32 bits, it's double word. Then group of 64 bits, it's L word. So these are the application when there is Modbus communication and bit masking application. In that case, we can go with this bit string. Then the another data type is a string or character. So whenever we want to show an alarm on the HMI from the PLC, then we can define a tag. For example, I want to show this alarm PFD is in halt. Okay, in that case, I will go with this data type called string, so that this alarm code will be reflected on HMI screen. Another application of this string is suppose there is a labeler system which applies label on a product, and I want to like paste production order, and it could be alphanumeric combination, for example a b c d 1 2 3 hash ab. So this is the production code I want to print on that product. So in that case also I will go with this data type. I hope it's clear here. Then another data type is a time. So whenever you are dealing with the timer application like on delay timer, on off delay timer, in that case you use this data type as a call it as a time. And if you want system date, then in that case you can go with the date as a data type. Then let's move to another data type, which is array. Array is nothing but a group of same data type. For example, So let's see from like basic example. Suppose I want to store production data. So I have defined the data. So in the first data, I will save the value in terms of integer, and I will save some produce count of the product. Then in data 2, I will save rejected count, and in the data 3, I will save, for example, rework product count. So this is the first approach I can follow, and there is another approach I can use here, which is just creating array. So how will I create array? Let's see here. So data from 0 to, let's suppose 0 1 2 of integer. So what does it mean? It means if I just expand this one, then it will look like this: data 0, and I can save a particular value here. Then data 1, then data here 2, and here I can save a value like this. And in system, it looks like this. So when I save a value in the first position, it will be reflected here like this. This value will be reflected here. And this data type is called as 1D. Now let's see other data types in the same array. Another type is a 2D array. In this array, this is my x-axis, this is my y-axis. And for example, this is array I have defined as a data. Okay. And for example, I want to store some data in this position. I will write logic like this: data position 0 1 2, then 0 1. Okay. When I execute this program, this 100 will be moved in this position. Similarly, for 3D array, for example, I want to store value in this position. In that case, this is my x, this is my y, and this is my z. In that case, position x is 1, 0 1 2 3 4, sorry, 0 1 2 3. This is 3, 0 1, and this is 1. And if I execute this program, this 80 will be written at this position. Okay, so these are the different types of array we normally use in PLC programming. Then another most important type of which is UDT, user defined tags. In other word, we call it as structure. So it is nothing but a group of different data types. For example, data, if I group yeah, include different data types like boolean, then integer, then real. So these are different data types, and if I group all together, it will form as a structure. So let's see this concept with an example of cake baking system. So here, baking system, in that this is my mixer, and this is oven, and after that, here the cooling things happen. Okay, now in this setup, I like make two types of cake. First one is vanilla flavor cake, another is chocolate. There are two types of cake I'm going to make here, and these parameters will remain same for both cakes. First parameter will be mixing time, second will be baking temperature, then third one will be like cooling time. If you see the mixing time, I will always go with the time as a data type. Then baking temperature will be in degree Celsius, which comes from analog sensor. So for that, I will consider real as a data type. Cooling time, it would be same. Okay. So for this, my I'm using these data altogether, so that's why I have to define a recipe as a tag, and this would be my structure. Okay, so I will create this tag, user defined tag in my program, and later on I will align this tag with this vanilla and chocolate flavor. So when I just align this tag with the vanilla, then the data type, if I select the recipe as the data type, then it will look like this: vanilla dot mixing time, then vanilla dot baking temperature, then vanilla dot cooling time. So likewise, I can give different values to these parameters, and this setup will work accordingly. I hope this data type concept is clear to you, and see you in the next video.